Question number 6, the mass of a non-volatile solute, given that the molar mass is 40, which should be dissolved in 114 grams of octane to reduce its vapor pressure to 80%. Options are 20 grams, B 30 grams, C 10 grams, and D 40 grams. All right. So first thing is the initial. Let's take the initial pressure. The initial pressure of octane. Let's take it as P0 of octane, right? So therefore, after adding a solute to this particular octane, the entire vapor pressure has reduced to 80%, right? So after addition of solute to octane, the vapor pressure reduces to 80%. That means 80 divided by 100. Now that is going to be as a 0.8 times P0 of octane. Now this is important to understand. This is the point that we need to understand here. Okay, so number of moles. The number of moles of octane is going to be equal to, as the molecular mass is 114 and we are adding also, it has been dissolved in 114 grams of octane has been used. So therefore, if we consider that, it is going to be as 114 divided by 114 because of the amount used. That is the amount of solvent that is used, 114 grams, and 114 is the molar mass. That means we are actually using over here 1 mole of octane, right? So therefore, now the next one is by using the Raoult's law. So from Raoult's law, from the Raoult's law, what we have an expression as P0 of octane minus P of that particular solution divided by P0 of octane is equal to X. Okay, so therefore, let's take this further over here. Okay, so therefore, what we are going to have over here is X2. First, try to understand what is the exactly X2. Okay, so X2 is nothing more than, it is equal to weight of that particular solute, which has a molecular mass of 40, the whole thing divided by weight upon 40 plus 1, because we are going to use just 1 mole. Okay, so 1 mole of octane, so that is the plus 1. All right, so therefore, proceeding further, we have P0 of P minus P over P0 of P. Okay, so P0 of P, sorry, or P0 of O minus P divided by P0 of O is equal to, okay, W over 40 divided by W over 40 plus of 1. Now, W over 40 that we would take into consideration, like W over 40 is nothing more than 1 over 40 into W. Now let's take this particular value. 1 over 40 would give rise to a value of 0.0. Okay, it is going to give a value of 0.025. Okay, as it's multiplied by W, we'll keep it here W. So this is what we are going to take over here. So it is going to be as 0.025 W times, so divided by 0.025 W plus 1 for simplifying this. Now, let's consider every single thing. P0 of O. Okay, so when we consider P0 of O, it's going to be as, what we are going to have here, P0 of O. How much do we have P0? Over here, we have taken as a 1. Okay, so over here, original, it's going to be complete P0, okay, minus 0.8 divided by 1. So this should be equal to 0.025 W times divided by 0.025 W times plus of 1. So now this P naught of octane is a whole number. It's a pure form, right? So let's take it as 1. So 1 minus 0.8 after reduction, after adding, it reduces. So it is going to be as 0.2 is equal to 0.025 W times whole divided by 0.025 W times plus 1. So now let's shift this one over here. So when we shift it up, so what we are going to get is that the entire term becomes as multiplying 0.2 with this particular thing, we are going to have it as 0.2 plus multiplying this one with 0.025, we are going to have it as 0.005 W times is equal to 0.025 W times. Correct. Now, let's take 0.2. Now, let's shift this one over the next case. So, when we shift it, so it is going to be as 0.025 minus 0.005 W times. So, therefore, W is equal to 0.2. Now, this particular value is going to be as, okay, it is going to be as around 0.02. Okay, so 0.2 divided by 0.02, and that is going to be equal to 10 grams. So therefore, this is nothing more than the weight of solute that should be added to the octane in order to reduce its entire vapor pressure to 80%. So therefore, the answer is option C. Thank you.